pyrrho video. Such an idiot. Anyway, this is going to be like shooting idiots in an idiot farm. Anyway, pyrrho comment. Wait. If patterns seen are easily recognized wave cycle mechanics. If they are easily recognized, can you show single slit wave mechanics that create a diffraction pattern in the single slit? 42 bars are created in the single slit experiment. Can wave mechanics duplicate that? Okay. And Pyrrho's answer is yes. All waves diffract. A preposterous statement, just preposterous. So I'll show you this thing later, but I mean it's it's a good one. You're getting good images, because they're all selective. So again, it needs to be understood that what's happening here is there's a little tiny experiment happening here that's a millimeter wide, and then it's projected on a screen over here into something that might be a meter long. So it's a huge projection from a little tiny thing to this big giant image. And there's lots of artifacts that are created by that, and consequences. There's another good image there. I've used that one a lot, but that's a good one for showing some things. But here's the little wave boxy thing. So that's supposed to be a single slit diffraction of water, right? It's fake. So this one's with 3 motors, and it comes out. The waves are off center. You can see here. Let's get to the single tank wave if we can get one, a good one. Here we have the interference pattern. So there's no evidence of anything diffracting here. I mean, to call it diffraction would be silly. They're waves created. They're not diffracting in the sense that unless you want to call the entire creation of the wave a diffraction. It's obviously not diffracting. It's bulging. I mean, clearly there's a friction created and the waves are bulging, and this is an enhanced image, of course, too, which is funny. But anyway, so it's the interference pattern, and the point is show a single slit doing anything called diffracting. It creates one wave, one bulging wave. You will not get a bar pattern with a single slit in a wave. It won't happen. All this wave comparison thing goes right out the window. It doesn't exist. It doesn't happen. And let's understand that the single slit with the opening made the same width as the double slit opening, the total opening, will give you a pattern that'll look pretty much just like this synthetic one, but that's what it'll look like. It won't have any of these breaks, so this is the part that has to be understood, is the tricky part. So this is what they traditionally show. But all you have to do is widen that slit. All you do is make this slit the same width as 2 of these. So just make this twice as big, and you'll get this pattern. Except with the center being much brighter, because there's an overlap. But that's the truth of it. Now these are multi-slit diffraction patterns, and these really don't look much like multi-slit diffraction. Usually the more slits you have, the bigger the dark bars get, essentially, and the things end up becoming dots. They lose their barness even. So I don't even know where they got that. I think that's another synthetic. But anyway, we'll stick with this. So anyway, let's go back to the question. So he's saying all waves diffract. So I guess it just depends on what you want to call diffraction. It's still a wave front. The wave front doesn't diffract in any way. So, well, all right. We'll just forget that. We'll just concede that, okay, if he considers diffraction being the fact that the wave, you can't really call it diffraction, though. It just doesn't make any sense. It's obviously being created by the friction with the surface. That this has been done is why there is confidence describing it this way. Well, again, he's asking you to explain the interference pattern in the single slit. There's not a diffraction pattern. We know what a single wave does when you bounce it off of a surface. You're not going to get any bars. It's not going to happen. Which depends on the wavelength and the width of the slit. It predicts the relative brightness of every characteristic of the pattern. No, it doesn't. So that's another. He's just saying this shit, right? This is absolutely. It doesn't do any of this. Predicts the relative brightness. No, all the brightnesses are not predicted at all by the math. Not at all. Where there's a dark and where there's a bright is predicted. The intensity, not predicted. Not predicted unless you augment the math to take into account the fact that it's a projection and it's being spread. But if you don't do that, it's not going to come out correct. Alright, also worth noting, Gary's theory is very consistent mechanical theme. You've picked up on that, the mechanical theme shown to work in all these various gravity, magnetism, time dilation, etc. Math isn't provided because it's not arguing the current math is wrong. He's arguing that conclusions drawn from the current math are misleading. To argue that, he'd have to know what is happening in the experiments and why the wave mechanics is employed. The math is wave mechanics. So that's what he's arguing. Now, I'll show you. The math doesn't account for any of the mechanics at all. It's just accounting for, again, on, off, on, off, on, off. But it's not in any way describing the actual effect. The actual thing produced is not being described by the math. And there is no way to make those equations based on what Gary thinks mechanics means. Yeah, he thinks mechanics means. Again, there is, but that's not really my obligation. My only obligation here in bringing this stuff up is to say you have no evidence that light is a wave, and your wave evidence is shitty. The two-slit experiment is not decisive evidence that light is a wave, because particles don't interfere with each other. Well, obviously the argument isn't that they're interfering at all. Their argument is that they're interfering with electrons, and that electrons will deflect photons. That's a known fact. They don't have trough and peaks to overlap. Well, again, it's not claimed it's an interference pattern. It's a diffraction pattern created by electrons that the photons are hitting. And if there was such a math, it would be identical wave mechanics and result. Well, again, it wouldn't, because your math doesn't even do the wave mechanics that are seen in the two-slit experiment. It doesn't match the results, at least to current accuracy of measurement, and would simply be another type of wave mechanics. Well, again, your current accuracy of measurement, clearly there's no consistency here. Their math is not accurate. But it's pretty clear there's no way to do that starting from Gary's idea of classical particles. Well, clearly there is no such clearness. What is clear is that you're taking a tiny relationship, the fact that in a two-opening circumstance there's a similar pattern in waves. There's not a similar pattern when one slit, and there's not a similar pattern with 3 slits or 5 slits or 10 slits. It's only with 2 slits. And you're assuming that because there's that similar pattern in one circumstance, that now it must be, we have absolute proof that light is a wave. Bullshit. Gary objects to metaphors drawn from math. I don't know what that means, but all he is metaphors that relate to no math. Again, that's just a lie. Obviously, the entire theory is based on matching the inverse square law, matching the fact that vectors of straight line force will create the inverse square. And wave mechanics has absolutely no applicability to things like gravity. Alright, diffraction pattern. Please consider the following. Do you have to use the wave mechanics of a photon? Rather, you can use the field mechanics, spin mechanics of electrons to explain that there is clearly good reason to believe that the surface of matter are not flat, dead things, and these extra electrons around the surface of everything. Couldn't the surface electrons have something to do with the pattern? Now, this is where it just gets crazy. Also, think of the photon as a hammer, not a wave. Yes, of course. Fiki, there is a derivation of diffraction from the quantum interactions passing by that surface. So there's nothing in any of the math that has anything to do with the surfaces. All of the math is based on a idealistic rendering of the circumstance, in the sense that all the math will be related to measuring from the open slit to the middle of the open slit. it'll have nothing to do with the surface whatsoever. So let's find this other better image. Hopefully, no, these are all. Here's the so here's the angle. All right, here's the opening. See they're taking the straight line versus the angle at which the pattern resides. So the pattern would be going out this way, and this is the angle theta that's part of the math. So it's always a projection out of the here's even better. You can see that right out of the center of the slit is what they're always measuring it from. There's no concession to any surface probabilities whatsoever. This wave is not created. It's always perpendicular. It's always perfectly centered on the center of the opening. There's no off-centeredness, or there's never any indication that the surfaces have anything to do with this pattern at all. So where does he get that crap from? I mean, he's not even arguing the standard physics. He's arguing some kind of physics of his own. This has nothing to do with anything physicists are arguing. It's the quantum interaction between the particle and the barrier. The quantum interaction, that doesn't even say anything at all, right? I thought the idea is that the photon goes through both the slits. It's just odd one particle reacts to both slits. Well, it's odd. It's in my opinion, it's ludicrous, but fine. Which is where the description of it being a wave on some level comes from. On some level. So now it's a wave on some level. So this is the fudge of this. This is just mush. So, I mean, what I'm going to eventually do with this two-slit experiment is go through all of the list of all the things we know about the two-slit and the multi-slit experiments, and try to isolate. Because see, the problem is they do each one of these experiments from a different distances, different widths, different barrier dimensions, and it just makes it all very confusing because there's nothing consistent to sit there and say, okay, here's things at exactly the same conditions. So even these images, these are all questions. I wish this website had the answers somewhere. I can't find the answers, so it'd be nice to have answers to the questions. But they're actually asking the question: are these two experiments done, with the same width? And obviously, you could tell they're not, because even though they're different colors, the only thing the different colors would do is change the phase of where the light and darks are. They would just shift the light and dark. Not the size like this. The size difference wouldn't happen. But anyway, let's get to this, because this is the more important kind of image. So these are patterns. So this first pattern they give you the numbers for. So it's half a millimeter wide barrier and a 400 nanometer wide opening. So the opening is 1/10 of the diameter. So the diameter thing is pretty big. The opening is pretty small in comparison to the diameter. 1/10 as big as the diameter. And so this is the pattern you get. Now there's no math that will, the math will work. Okay, yeah, get this bar right, get this bar right, but it won't show you this bar going almost to zero. It won't show you this at all, this empty space. And then it won't show you this gradually getting brighter again, then get dimmer again, and this empty space, and this gradually getting brighter and dimmer again. None of that will be shown. Now the other thing to be clear on is you can see the projecting effect here really well. You can tell that this target was pretty far away from where the experiment was performed, because you can see that the distance between the slits, the dark space, you can see how much wider it gets as you go further out. So as it's being projected, it's distorting the relationship. So the mathematical relationship is not the same anymore, because everything's being made bigger. So everything on these fringes is made bigger and bigger and bigger, which is a distortion, but I mean it's just something that's kind of a giveaway of the distance. But the math doesn't do anything to deal with the fact that there's this same pattern repeating. Now what's curious is no matter what this number is in this middle, like there's like 18 of them here, then there's 9 here and 9 here. So it's multiples of 9, and they just get dimmer so you can't see them all. But that's sort of giving it away in a sense that it's really, what this pattern really is a bunch of these patterns, and these two are so close to each other that they've fused together, and the light from the opening, from the tiny ½ millimeter opening, is what's hitting this middle to make this middle brighter. But it's really just this and this smashed together. And so this one only has 13, and so there's 6 in these extra patterns. So you can see that it's obviously, this is what everything's made out of, is these multiples of 6. And this center just has 2 multiples of 6, because that's where the 2 patterns start. And that the diffraction pattern is, in essence, if I have a slit here, it just diffracts this way and it diffracts this way. There's no anything else. And it's just the initial pattern overlaps. So I started drawing it, but I mean, it's a bad drawing, but it's something to get to. Because you sort of have to understand that the slits are way back here, and then your pattern is way down here. But the stuff going through the middle just goes straight through. So the first band is always going to be a bright. But the patterns off these other 2 slits, the 2 red ones are obviously ones going this way, and the blue ones are going this way. But they're 2 opposites of each other in terms of the circumstance. One's in the middle, one's on the outside, one's in the middle, one's on the outside. And that's reflected in this overlap. So they have a whole wavelength of the ones going the same way where they're staggered. So the center ones are bright, then you have a dark. This should be a dark here, obviously. You know, so you would see that this is, I should have filled that in dark just so you could see that that would be a dark. But you just look for the brights. The brights are the ones that matter. So the center would end up a bright, even though, well, I won't go into it. But this is where the diffraction pattern overlaps. So this first one happens here, and then the second pattern starts 1/2 wavelength off. So these darks will end up lining up because the 2 will overlap each other, and the same is happening over here. Now, I can't as yet make that do this. Again, this repeating pattern of a repeating pattern. So it's kind of like a fractal in the sense you have 6 things here, and then you have these 6 that you can see. Obviously there's more, I should spread out further. But the fact that this center is made out of a multiple of these 2, so it seems kind of obvious that this is where there's 2 patterns. There's this side, and they're both made of these 6s jumping. And as you get more slits, what's really happens is these things just turn into blobs. Gee, what else did I want to say about that? But that's the real key to understanding this thing, is this pattern. You know, this kind of wave idea that's in here. This kind of, the fact that, like I said, and there's no math that accounts for this. So I'm just saying, they can say none of this math will give you, the math will just pretend that the pattern looks, you know, I'll go back to the easy drawing. I mean, it'll just keep pretending it's a clear pattern when it's not. It'll just give you this, for the synthetic, it'll give you this. This is what the math will say the reality is. This is a synthetic. And clearly this is the result. So the 2-slit math will tell you it looks like this. This is the 2-slit result. So I mean, it's just very dishonest to say that they have math that's describing this experiment, because it's not. It's, and again, the math describes a single slit. If you just make the width wider, this single slit will look just like this. Fact. And it certainly won't do that in waves. Alright, so anyway, but the point is somebody's got to go through all of this and find it and write down exactly what changes everything. Like I said, the width of the slit creates more things. The distance from the surface, obviously you're going to be able to resolve more or less of the pattern depending on how far away you are, and how much light can get through. a lot of little factors. The tricky one is I haven't figured out what exactly the dimension of the impediments, what effect they have. Like I said, they obviously in one of these patterns, okay, they probably changed this width to a smaller width, and that's probably this bottom one. And this one, they probably just went with a wider or narrower slit width. So this one's a smaller impediment, a smaller impediment in the center, and this one's a larger slit width, I think. So anyway, all right, let's do the Hoffler-Day thing. So let's finish that. I thought I had more on that two-slit, but I'm gonna let it go. Like I said, I don't need this. This two-slit experiment is just totally irrelevant, only to the point where I'm arguing that any evidence there is, rock solid evidence proving that light is a wave, isn't solid evidence. And that what we know about light, and what I know from all the physics I had in school, and what I realized playing with electronics and doing everything I've ever done, is that we know that photons have a period. We know that's really important. And we call a wavelength and a frequency. But those are just extra words to describe the period. And the wavelength just ends up creating a number that goes bigger as you get a number that gets, frequency ends up being a number that gets bigger as you get a smaller period, and wavelength gets wider as you get a smaller period. It gets smaller. Wavelength becomes a smaller number. Well, anyway, they're inverted, and that's all. Frequency and wavelength are exactly the same thing. They're just inverted numbers, and both of them are the same as the period. The whole thing is just such bullshit. Why would you need 3 ways to describe something unless you were playing mathematical games with the numbers? Using one number because it gave you an inverse relationship. Yeah. So I think that's enough of that. Yeah. Okay. So Hoffler-Day. I don't know. I'll play like the middle part where he starts to get to something relevant, but I don't know how relevant it is. He's pretending this is somehow a emendum dancing principle, like he agrees with something, but he does it in such a poor manner that I'm like, what's the point of agreeing if this is what agreement looks like?
Well, principles, like Einstein generated his equations by one of the principles. The general relativity was the principle of equivalence between acceleration and gravity.
Yeah, I know, but that principle is just so obvious. What the hell does that have to do with anything? I mean, frankly, I just don't see anything very bold or interesting in saying that acceleration is acceleration. Yeah, duh. I don't know why somebody thought the acceleration of gravity was somehow different than the thrust of the engines that overcome it. I mean, it's the same acceleration. There's force A and the opposing force B, and the forces are the same. Why would I think the forces are any different? I mean, I just thought that was kind of a equivalence is kind of a, I just don't see how it's relevant, but I guess to Einstein's sense it's only relevant because then he can say that velocity has something to do with bent space. Because now he's going to say because they're equivalent, that means they're both being caused by bent space. Because he's saying gravity is being caused by bent space. So now we have to say that velocity is being created by bent space or something, I guess. But yeah, I don't see the usefulness of that. Sorry, getting a piece of paper. Find my damn pens. For everything. So anyway, so we'll go down a little further.
Because it's way more philosophically palatable to conceive of the idea of metabolism changing, and I endorsed the idea and thought it was a good idea way back when about the metabolism of an atom.
Yeah, whatever. I don't
practical
I don't even buy that
a good
point that you thought it was a good idea. I don't think you've ever said anything decent or respectful or whatever. But regardless, you've said plenty of other stuff, so, you know, whatever.
concept rather than the invocation of space-time.
So that's his big, bold endorsement. Now he'll do his butt, hopefully, because that's what I want to get to. This is the butt.
It's and if I thought about it, I could write it down. But it is as Mendham said, a kind of the reason it's more palatable is essentially the Occam razor reason. Yeah.
Well, I won't bother with this because now he's going to say Occam razor didn't really mean that, but that doesn't matter.
The dance part of the principle is when he talks about it in terms of arrows, and I think I might have a better explanation, or because it's, you know, we're trying to talk in terms of particles, and the abstraction of talking about arrows, I think, loses some of the mechanism.
Yeah, well, he concedes later that arrows are probably okay, and so, but you know, the whole point is there's nothing about these quantum particles. Okay, these are the thing everything's made out of. This quanta, this thing, photon, magneton, graviton. They're all the same thing. They're just these little tons, and they make everything else. Nothing else is a particle but these. Electron. A tron is not a ton. So an electron is tons. So everything is these orbits. And, you know, he does a little, well, I'll show it, but he brings up Lorentz transformations, and so I wanted to get to some of that because, you know, Einstein has a problem because, you know, it's like his singularity thing with gravity. He creates this idiotic math that makes it possible to somehow put the whole universe on the head of a pin, and it just, you can't do that to energy. You certainly can't do it to matter. And the whole Lorentz transformation, as far as I understand anyway, you know, Newton has his put in his own. This is calculus or whatever, right? So this is like trying to put things into motion, and you know, what happens over time. And I think their problem is they can't allow it to exceed the speed of light. So they had to put some sort of proportional limiting factor in. But clearly I'm arguing that you're going to degrade the matter long before you get to the speed of light, so this problem isn't even going to exist. But even if you had to surmise some kind of problem in terms of energy needed for acceleration, let's say, you could imagine that as if I'm arguing, I've used a second analogy I've used is that as you gain velocity, the targets that can be hit inside of you get smaller and smaller and smaller. So the faster you're moving, the less targets you have in this perpendicular dimension that can be hit by force to propel you or change you. So the argument would be is that if you were pushing something with a force, and those targets are getting, because it's moving faster and faster, and you're applying more and more force, that as the targets get smaller and smaller, the probability or likelihood of your force hitting a target gets less and less. So you have to create more force because you have smaller targets to hit. And so that's where you would get into this argument that Einstein would argue that matter gets incredibly massive. Well, it gets exactly the opposite. It gets so unmassive that it becomes really hard to hit anything in the matter because you've lost all the mass. All the mass is going the speed of light away from you, and only a tiny percentage of it is doing this tangential, this perpendicular thing that you can hit, these targets, the little ducks. It's like ducks at a shooting gallery. Well, just pretend that the ducks get smaller and smaller and smaller as you go faster and faster and faster, and it gets harder and harder to hit a duck. Well, anyway, so that's one way of disposing of that. But as I'm saying, I would argue that matter won't survive this journey anyway. long before it gets up to any kind of speed, it's going to start getting annihilated by photons. It's going to get annihilated by the smallest things. Well, photons I shouldn't have said. Well, even photons will disturb it because they become radioactivity, essentially. They become X-rays. Light will become X-rays because you'll be increasing the frequency of the light you're heading into, and it'll disrupt whatever electrons you have left, or other material objects will start getting broken down by that radiation. But yeah, any piece of matter you actually hit will just start annihilating you. And so there's another way to look at this velocity argument that he's not getting either, is that if you really understand velocity as a degrading of your material structure, then you can understand why you can be annihilated by a speck of dust. If I'm moving fast enough through space, a speck of dust will blow me up. And why will that happen is because it has nothing to do with momentum and mass and all that shit. It has to do with the fact that my matter has now become very weak, because it's doing this velocity thing that's degraded the strength of the bonds. And all the bonds in my matter are now getting weaker and weaker as I go faster and faster. And now smaller and smaller things will penetrate, because the castle walls are getting thinner and thinner, so to speak. And that's a really important... it's so intuitive to think about this idea of momentum equaling force. You have matter in motion, and it's the force, and so you're making the explosion bigger because you have more force. But you really don't. It's that you have all your energy, all your masses in one direction, true. But what really makes you weak is the lack of stability in the other dimensions. And that's the part that's, you really have to, you have to think about it a little bit. But when you do think about it, it's so obvious that what makes velocity potentially explosive, destructive, is the fact that your matter is weakened by it. Alright, so the rest of this is just going to get to this arrow thing, and so I just figured I'll do a rough sketch of some kind to do this idea of something having more direction in one direction. Alright, these two directions would be equal. So Hothloday is thinking about a rectangle, but it's not a complete rectangle. The catch is that the rectangle has far more direction this way than it has this way. And it has to move because of that. So yes, you could think of it as a rectangle, but it's not a finished rectangle. It's clearly got more directionality going in one direction. And so it's like a hurricane or a storm you could think of as having more energy on one side of it than the other side, and therefore it moves with the side, in the direction of the side it has more mass in, because that has more, it's an imbalance. And that imbalance, so if I imbalance this arrangement of arrows by putting many more arrows on one side than there are on the other side, the thing itself will have to go this way. It'll be forced to wobble off because of that extraness in that one direction. But the real point that is critical to this understanding of velocity is the understanding that head-on collisions in kinetics are zero. And so the only way this extra force can affect anything is in the tangents. And it can't affect the tangents because they can't move. They have to wait to be moved until this gets to its new location. So if you think of it as this arrow imbalance thing, you have to think of it as that this storm has to get to its, this is really hard to explain, but this has to go the extra distance before this can go down. So this doesn't really exist here. The tangent doesn't exist where it would exist. So this is dead space to the tangent. And that space, as you can sort of understand that the faster this thing's going, the distance this is biting off before the tangent comes down gets wider and wider and wider. And so the tangent, the perpendicular directions, the up and the across to the velocity, exist less and less and less the faster you're going. The tangents don't drop at the same time. And that's the real difference. So obviously they're not here. They don't exist for this amount of extra force you're running into has nothing to hit because they're not there, if you get my drift. And it's proportional to the velocity. So you're going to miss. The targets get smaller as your velocity increases, so there's less to hit. I mean, it's just that simple. And that's what you really have to understand is you start off with no velocity, you have a solid big target, you can't miss it. And as the velocity increases, they get smaller and smaller and smaller. So just think of it pixelating. And then those balls get smaller and smaller and smaller, and as the faster I'm going, this gets harder and harder to hit because the this gets smaller and smaller and smaller. That's one way to put it. Well, let's see where he goes.
And so I hope maybe this is some kind of improvement. Right, so I have two particles. Hopefully they're on corners of a 10 by 10 square of dots, right? And if you
okay, so I'll use his description. This is just really for him because no one else is going to understand this. I mean, he was using these to just illustrate the idea of the relationship between these two in sense of a gravitational or whatever, a magnetic relationship, a charged relationship. And I don't think for the purpose of the argument there's any point in thinking about this field mechanics in terms of individual things, because the real point is the individual things are constantly changing identity. So this little thing doesn't exist as this thing. It exists because it's going to other things are constantly hitting it, the force. And as that's happening, it's constantly changing its identity. It goes here, it goes here, it goes here, it goes here, it goes here. And the point is what are the tendencies based on the force dynamics. So again, we're back to this field argument, but if I am a thing and then I interact with the external world and it changes me to some other thing, then this thing is now plus one of these things in the environment, and because I have this one, the environment is minus the opposite of that. You know, and this is the field. So there's these idea is that the entire matter, when it's getting moved, ends up as a net field, has to somehow have more arrows, a lot more, going one way than going the opposite way, clearly. And to do that, it left in the field an exhaust, probably, right, kind of sensibly, going the opposite way. A lot of arrows going the other way, a laser beam or whatever, however you want to think about it, that gave it this extraness. So it expelled into this greater field that stuff. So this now, as its field of interaction, is balanced. If you just think of, if you encapsulate that entire area, you would still have an equal balance because now you've got back your pieces. But you can just see that the field dynamics are constantly going to be fighting between how far away your exhaust has gone. And if your exhaust doesn't get all the way away because there's some imbalance in this bigger field, if there's an imbalance in this bigger field going in this net direction, then this might get dragged back and be in your face again. So you might run into your own essence. You know, what you did, the smell you made, you know, might drift back to face you again. But yeah, see, this just, you know, I'm not saying there isn't something discrete about the mechanism. I'm saying to really understand the mechanics, though, you would have to understand that this is constantly being, this is in a constant state of being fluxed, you know, moved around by the force, and it's only over a probabilistic period that this adds up, you know, that you end up changing a certain amount, flipping, going heads, and then you go tails, and then you go heads, and then you go tails. You know, in terms of if you were flipping coins, you'd have more heads, and then you have more tails, and then you have more heads, then you have more tails, and it's constantly flipping. And it's only when you change the overall dynamic by taking some heads off the coin, so to speak. You know, it's like rubbing a number off the dice. Now your chance of rolling certain numbers gets different because you've changed the shape of the dice, so to speak. That's not a great way to say it either. So anyway, he was doing this thing where he's having this pattern and he throws a penny in here each time the thing has to jump. But he's like maintaining this, and it doesn't really get maintained. These two items are not going to be a way of representing velocity, because velocities, it's just going to be about these tangents, and these tangents getting smaller and smaller. And the fact that obviously this dimension is also shrinking, you know, the one going the opposite direction from this forward one. So there just ends up being more of these balls going this way, less going down, and certainly less going that way. But that's really the arrangement. You have the same number. Let's say if you had a full box of these, you're just changing the shape of them. So more of them are on this line and less of them are on this line. And these tangents are equal, but they just keep shrinking as you make this line longer. So as you get more and more arrows going this way, you'll get less arrows going this way and this way and this way. I'll have to do. So I'll play some of this, but you'll get that it's not a very good analogy.
Yeah, so he gets back to you, he throws in. Yeah. I don't know whether this is going to work out. And so
yeah, it wasn't working out.
no, I don't think that works.
Yeah, I don't think that works.
In the transverse directions. Oh, I knew I should have.
Yeah, he dropped this little thingy. So yeah, it didn't really go very well.
So when the male, let's call him, gets back to here, you wouldn't.
Yeah, see, I don't want this dance. He's turned my simple analogy of dancing into some partner thing, and the partner thing is only significant in understanding that that's what's holding this storm together. Okay, that's what keeps it from just flying apart. But it doesn't really have anything to do with once imbalances are created inside the storm. So the imbalances in the storm really don't have anything to do with this partnery thing. I mean, it always applies, but I'm just saying, obviously it doesn't have to apply in any kind of even number once you have movement. So the fact is these here, because nothing changes speed. So again, you just can't do this ellipse thing. You can't, you know, an imbalance is just a raw imbalance. It'll just have a funny shape, but it doesn't change. There'll be no change in speeds or change in anything. It'll just end up being that there's just more stuff going one direction. That's just the way it's going to turn out. There's just going to be more arrows. I don't know how else to put it. There'll be more bits that have that orientation. And it's just the way it's going to be. I have to say that without... And it'll be that way because of some other relationship. Like I said, the fact that they'll get closer and further apart. You know what I'm saying? That at any moment, say there's only 5 of them here and 10 of them here, and so we have to gravitationally still bind these things together. Well, the argument could be that these 5 move in closer to these 10 and then move far away again, and then move in and then move far away again, move in, move far away again. So they multiply their ability to gravitationally connect. But again, we know that nuclear forces are more like electrical charge or magnetic forces, so it's probably polarized. That is, it's on a single dimension. So they're able to maximize the strength of that attraction and repulsion. But I think that's going to be part of the equation here, is that things are held together not because they necessarily have balance, but because they have some sort of orientation that causes balance. So the way they move is going to have just as much to do with what their orientation is. And if they move a certain way, they can pull more, they can create more gravity than their numbers would indicate. So I'm just saying that's what ends up balancing them, is the directionality of that movement, because it doesn't have to be a circle. It can be any shape. So it could be doing a triangle. The 5 could do a triangle, and that would still bind the 10, so to speak. But I don't want to get into all that. I mean, like I said, this is the kind of minutia that I don't think is necessary. The point is that the idea of quantizing the element of the substance of the thing, and understanding the spin dynamics, and understanding that spin is probably necessarily associated with movement, I think fits. So, but anyway, yeah, I don't know if I want to get that deep into that. I mean, but I'm just saying this is I just don't think this abstraction, and certainly worrying about the partner part, does anything to analogize the fact that you lose your tangential realities, your perpendicular dimensions, as you gain velocity. It's like if it was 3 gyroscopes that made you. Okay, so there's a gyroscope spinning this way, and they're all tied together. One spinning this way, and one spinning this way. One spinning this way, one spinning this way, and the other one would be one spinning this way, one spinning this way. I know it's there somewhere, this way. Okay, so you have 3 gyroscopes tied together with those 3-dimensional movements. The point would be is that to do this forward one, if you were going to think about it as rolling spin, you know, it moves faster, the other 2 start moving slower, kind of thing. It's like whatever the total thing is between those 3 dimensions, that's always conserved. So for this dimension to do more, these other dimensions have to do less. I think is the better way to say it. Better way to describe it. So I just don't think this does it. But anyway, it's a matter of there's so many ways to analogize. Like I said, I can just go with school of fish, I can do dancing, or I can just do the absolute argument, which is if you just concede you're made out of energy and that the energy is still moving, that all you have to do is imagine what would happen if you start moving the speed of light, that all of you would be going one direction, and it couldn't possibly be going any other direction. So if I move my matter the speed of light, then all of my matter has mass in just one direction, and I'm basically a laser beam. And that, you know, I'm not matter anymore, I'm energy. Big pile of energy, but I'm just energy. Alright. I mean, I could certainly burn holes through frickin', you know, I mean, if you turn me into a laser beam, right? If you take all my mass and convert it into photons moving the speed of light, yeah, I could bore a hole through the earth. Alright. That's enough, I think. So anyway, I didn't do as good a job as I wanted to on this, but close enough. But I mean, Pyrrho's just so wrong. He just doesn't understand the 2-slit experiment. He doesn't understand the 2-slit math. I've never seen a mathematical equation that deals with this phenomenon at all. If you do the 2-slit math, like I said, it'll give you right answers. It'll get a wrong answer for this dead bright here, the bright that should be here that's dead. Here and here and here. That missing bright, it will not get that correct. That change in phase. And it's essentially a change in phase if you think about it. It's like having 2 darks next to each other. It's like it changes the phase. Okay. Enough said. Till next time.